Okay, we're back. We're up to Section 8 of our Chapter 12 review for the Chem 4 final, and we're covering, this is Part 1 of the colligative equations. Whenever you add a solute to water, three things change: the boiling point, the freezing point, and the osmotic pressure. These are called colligative equations. These are called colligative properties. Now I want you to look at the formulas for boiling point increase, the amount it increases by, the freezing point depression, and osmotic pressure. And if you look at them, you'll notice all three of them have something in common. They all have the Van Hoft factor, which we just studied in the previous video. So if you skip that, go back and watch it. So when you add a solute to water, the boiling point is going to increase by a certain amount. That amount is the change in boiling point temperature. If you add a solute to water, the freezing point is going to decrease by this amount. So you're going to take your original freezing point and you're going to subtract whatever you get for here. For boiling point, whatever you get for delta T sub B, you're going to add to the boiling point of water. And whatever you get for freezing point, you're going to subtract the delta TF. And then we have osmotic pressure. So I'm going to leave our thermometer up here. So you remember boiling point always goes up and freezing point always goes down. So let's start off with a freezing point example. Remember, these values are added to or subtracted from. Added to boiling point, but subtracted from freezing point. Okay, so here's our example. If 25 grams of glucose and with a molar mass of 180 grams per mole is dissolved in 125.0 grams of water, and they give you the molar mass of that also, I don't know why, and they give you the freezing point constant. That's the F. Freezing point constant is equal to 1.86 degrees centigrade per molal. What is the new freezing point of the solution? Okay, as always, let's start with the formula. Our change in freezing point is I K sub F molal. And remember now, molal is going to be moles of solute per kilograms of water. So let's see if we can plug anything in yet. Change in freezing point is I. Now what's I? Look at the compound. Is it a strong acid, a strong base, a polyatomic ion, an NH4 salt? Or is it a sugar or a protein? If it's a sugar, like glucose, or a protein, it's not going to separate into positive and negative ions. It's going to stay whole as one particle. So we already know I is going to be 1. Because sugars and proteins don't separate into positive and negative ions. K sub F, they give us 1.86 degrees centigrade per molal. So that leaves us with finding molality. So let's calculate molality. You'll remember from when we talked about concentration that molality equals moles of solute, in this case glucose, per kilograms of just water. Did they give us moles of glucose? No. Because we chemistry teachers like to make your lives a little bit more miserable than when you came in. But they did give us grams, and so we can use our lifesaver equation number 1, which tells us that the number of moles equals the number of grams or mass you have divided by the molar mass, which they gave us. So number of moles in this case is going to be equal to 25 grams divided by the molar mass of glucose, which is 180 grams. So our number of molals is going to be 1.112 moles per kilogram, or small m, molal. So now we just plug in. Molality equals 1.112 over, what's kilograms of just water? They gave us 125 grams of water. We don't want grams, we want kilograms. To go from grams to kilograms, 1, 2, 3 places to the left with the decimal. So 0.1250 kilograms of water. And when we divide that out, what do we get? Oh, we have to plug it in here. I'm going to erase this and plug our molality in here. 0.1112 molals. See, we used our lifesavers. It's very handy. You're going to use them all the time. So our delta TF end up being 2.06832 degrees centigrade, because it's a temperature. Remember SUN, significant figures, units, and number. We have our number, we have our units. Let's do significant figures. Go back to the problem for that. We have 3 significant figures here, 4 significant figures here. We're going to make our answer 3 significant figures. So we have 2 points. Since this is 5 or greater past our 3, 2.07 degrees centigrade. Now this is where you're going to screw up. That's not the answer. This is the amount the freezing point goes down. So since we're dealing with water, we're going to start at 0 degrees centigrade, and we're going to subtract 2.07 degrees centigrade. So our new freezing point for water is minus 2.07 degrees centigrade. Voila! I'm going to cut here, and we'll come back with our second colligative equation for freezing point, which is very similar to the one we just did, so it will not be so bad. I'll see you then.